Hello friends, welcome to a new video. In the previous video we unlocked this Lenovo laptop battery using the BQ8030 with the CP2112 board, and this time we will unlock another board. I already discussed this is a Chinese laptop battery and this was the original board. It is from the HP laptop. You can see, let me zoom. You can see it is using the, I think, BQ4050R1 chipset using. Unfortunately, the chip is dead. Some of the resistors, capacitors, and some are, it's not in a good condition, but the fuse is good. The fuse is controlled by the microchip. It is good, but in the Chinese chipset, let me take. You can see it is uses the BQ4050 chipset, and there is no fuse, only using two MOSFETs, a normal fuse, and there is no melting fuse in this board, and we are using the CP2112. So this is the back cover of the battery. You can see it is saying 14.8 volt, 2200 milliampere, 33 watt hour, and made in China. You can see it is still under warranty, but the battery is not responsive, so my brother gave this battery to me. And the interesting thing is this battery only has 2000 milliampere, not like the 2200 milliampere, so that's the bad thing. After all, this is a Chinese battery. I don't expect anything, but let's try with this board. And this is the part 1. In the part 2 I will use the Raspberry Pi Zero board. In the part 3 I will use the Arduino Uno board. I know so many of my friends tried with this board, the Arduino Uno board. I tried the BQ8030 also with this board, but we can only read. Then later I read the ROM with the FX12P board. So but this time, like this chip, the BQ4050, we can use the Arduino board. I will show you in the third video. This is the first part, so please watch the next two videos also. And let me, okay, now we need to connect the data and clock pin. There is markings on the board as C and D. C is the clock, D is the data, and P minus is the battery, and there is a not connected and the P plus. So we can connect the battery and then connect the micro USB. And I have successfully connected the CP2112. Let's open the DJI battery killer. Okay, it is connected. Click connect, and you have three options here: BQ30 is a 55, BQ9003, BQ9006. So if you are using the BQ30 is a 55, this chip will not unlock because this chip uses another type of mechanism. You can see the chip is in the sealed state. The voltages are good. I already changed some parameters. You can see the full charge capacity I changed to 2000. Decent capacity still I am giving it as 2200. Cycle count is 256. This has only 3, and I wondered why this will not changed. And you can see the temperature is remains same because there is no temperature sensor in this board, so that the temperature will remain the same. You can see there is no warning. The max error is 100, RSOC 99%. Overall the battery is showing good, but it is sealed. If you click on the unseal, it will uses the SHA-1 authentication method using the HMAC, but chip still sealed. Why it is happened? Because the SHA-1 key, maybe the key is not correct, the key is different for this chip, but we can unlock it with by using only the unseal key and the full access key. So let me open one of the important document from the Texas Instruments. Let me open it. So this is the technical reference from the BQ405055 revision 1. It is released in the 2015. So we can use some technical details from this PDF. So let's check the firmware version, the manufacturer block access. You can see permanent field data, security keys, it is stored in the 84. So you can see, to read the security key we need to use the block command. So I'm writing as 00, here also 00, writing 3500, right block, read block. Nothing happened. Okay, try 44, right block, read block. It is showing some default values because the seal is the chip is in the sealed state. So let's try some default keys. As you can see in the PDF, it is 0414 and the 3672. For the default full access, the key is FFF and FFF, so it is already in the PDF. And if you choose the BQ9003, it is already added in the unseal key option. So if I click on the unseal, we can see the key 1 is entered successfully, key 2 is successfully ended, and chip is unsealed, and key 2B successfully ended, chip is in full access mode. So if you try this command, right block, read block, we can see the previously it was showing this value, but now it is showing the keys as per the PDF. The security keys 003F should given the output 1404, which is same 0414, that is a 1404, it's in the reverse order, and 3672, that is a 7236 here, and FFFF. So the chip is in the unsealed state, that is in the full access mode. Now we can do anything with the chip. For this chip we don't need to read the firmware, we can edit the values directly in the full access mode or the unsealed state. So if you want to change the cycle count, you can read a word 0100. So click on the 17, the right word, I am typing as 0, right word, read word. Now you can see the cycle count is reset to 0. Now if you want to change the full charge capacity in the 10th register, so 10. Now it is showing in the hex value. So what is the hex value for 2200? Let's try. I'm using the Microsoft calculator. Previously I used to some third party app, but our Microsoft can gives this type of calculator by click on here, click on the programmer. I recently found this, sorry for my last video, And now we want to convert to the 2200. Let's check. The 2200 is 098. Okay, let's try what is 2000 is showing us 7D0, that is 07D0. We need to add the 0 before the 7. So here I need 2200 showing the hex value 898. So we need to give the value as 0898 and write word. Now just read the word. We can see it is changed to 2200 milliampere, but I will change to 2000 because the battery is only showing 2000 milliampere. And also we can change the design capacity. It is also lesser than the actual value found in the chip. It is 2000 only. So let's give back the right value, clicking on the decimal 2000 07D0 and typing it as 07D0. Write word, read info. Now you can see it is changed to full charge capacity. Now what about the design capacity? Showing 2200. I am writing it as the same word. Now read capacity, read info. Now you can see design capacity is also changed, and the RSOC and the absolute state of charge is also becomes 99%. The max error is 100%. So this is a simple way to change the cycle count and the FCC. And if you have any errors like the permanent failure, so click on the registers and let's see what these IC showing. So you can see, so if you want, you can do this before doing this all. I'm just showing because in this chip this is not a big deal. All the registers are showing good, I think, unless this SV Qmax is showing LED enabled, lifetime black box recorder, discharge. The gauging is enabled, I think. The charging status is enabled. STL is showing. Okay. So what are the general registers? On the battery mode, you can see charge M. The charger mode is enabled. Alarm mode is enabled. And internal charge controller is enabled, ICC. We can see it is in the 0-1 state. That means it is in the full access mode. Initiated, discharged, charge, discharge, PRES is enabled. So basically the chip is good because there is nothing to change. No need to worry about the fuse. I already show you the fuse is here. You can see the fuse. Here you can see the fuse, but on this board there is no fuse, so we don't need to worry about the fuse. So that's it. And click on the unseal again. You can see it will, chip is already in the FS mode, so it not need to unlock. But if you click on the BQ30, it's a 555. After the chip unsealed, let's see what will be the result. Now you can see the chip is showing as unsealed. You can see change keys. You can see the challenge here. Unseal. Okay, now you can see the key is changed. Right word is 0035. Now you can see it is in the 0035. It should be in the 0037, right? Maybe that's why. Okay, unseal and the full access should be like this. Oh, that is why it is red. Okay, then try it. Authenticate. Now you can see it is righted to the 0037. Let's read info and let's unseal. Challenge is showing the same. Is it the same value before? 57C Is it the same value? Yes. Then okay, try seal, unseal. Now you can see it is not working. The SHA-1 authentication is not working for this chip. Maybe the chip is not with the SHA-1 authentication. As per the PDF, it should given a authenticate value, but there is nothing like this in this chip. That is why we should worried about the Chinese chips. It is not a good thing. The Chinese, they're making very cheap bots, cheap batteries like this. This will damage your laptop. This will damage your laptop adapter. This will damage your motherboard, the power section. Okay, the second thing, how to clear the permanent failure. We have a code here 0029. So don't try the black box or the lifetime. Maybe it will entirely wipe your data, like the charge. The chip manufacturer gives some values to the chip, to how it works, how it should behave, how the cells to be charged, something like that. So if you click on this, you need to I think you need to reset it again. I don't know more about this, so I'm not usually do this. I want to, if your chip is not showing any values, if it's showing in the permanent flag, here you can see PF. Where is PF? You can see the PF here. A bit is enabled, a flag is enabled for the PF. You can give this command 0029. What will be the result? Let's try. 0029 means 2900. Now right block, you can see it is right. So nothing changed because already it's in the, already the chip is in the working condition, so you don't need to change the what to say, you don't need to change the permanent failure thing. Now is it possible to change some other values by using this software? It's very dangerous because we have choose the BQ9003, but this chip should be behave like a BQ4090 or something like the BQ3055. Unfortunately, this will not unseal with the authenticate function, so I am worried. I don't know why this is showing like this. So if you click on the full access, what is this? Okay, authenticate. It is saying the values as this, but it is not working. Anyway, what is the capacity voltage? Okay, read values. It is showing some random values like this. I don't know why this is showing like cycle count, descent capacity showing 0. Maybe it is wrong. Firmware, read EEPROM. You can see the chip is not in the boot mode. Here we need to enter the chip into the boot mode manually, because this code will not work using the BQ055. Also the BQ900, if you click, it will not work because the code is not correct. That is why I told you the chip behave like something else, not like a good chip. So what is the command to enter to the boot mode? Let's try with the PDF. It is showing us 0F00, so we should given here as 00F. The value is reversed rightward. Now go to the firmware. If you click this, it will again show. Untick this, click on the read EEPROM. Now you can see it is started to read. Okay, it is showed some error. Is there any problem? Chip is still in the normal mode, not entered the boot mode. That is why it is showed an error. So what is happened? Rightward showing read info, not in the boot mode. Okay, that is why Okay, let's try 0F00 right word read info. Now the chip is entered in the full mode. I think in the if you write in the block access the 44 of the manufacturer block access, you should reverse the digits. I don't know, something is going on. If it's showing the values like this, it's in the boot mode. So click on the read EEPROM. Now it is started to read the EEPROM. It will stuck, don't worry, it will take a minute. Okay, it is completed. I'm going into the folder to see if it is there. Okay, here you can see 3 files. This is from the capacity and voltage section. This file is created, and this is the 0 KB file because the firmware was failed. Reading EEPROM, it is showed an error. So it is showed an error, and this is the 8 KB file. I'm not going into about it because I'm not I don't know the values about which register contains the which offset contains the values. I don't know nothing about this chip. If you want, you can refer this. If you want, you can refer this PDF. The flash mode, and how to exit from the flash mode. The chip is still in the flash mode. If you click on the exit boot, it will say chip not in boot mode. So go to the command, type it as 08 send. Now read info, chip back to the normal mode. So that is how we unlocked the BQ4050 Chinese chip, not the, I don't think it's the original Texas Instruments chip. No idea. Anyway, that is it. That's it. Anyway, that's it. And if you have any extra boards with you which you don't need anymore, please send me. I will try to make some videos with the Arduino, the CP2112, also with the Raspberry Pi. So that's it. Thanks for watching. We will see again. Be safe.